Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the mechanics for February-March 2024, and the code is 9709/42. So let's move on to question number 1. Question number 1, the displacement of a particle at time t seconds after leaving a fixed point O is s meters. So here is S meters against t seconds. The diagram shows a displacement time graph which models the motion of the particle. The graph consists of four straight line segments. The particle travels 50 meters in the first 10 seconds. So from here, we know that this is 50 meters in the first 10 seconds. Okay, after that, then travels at 2 meters per second for a period of 10 seconds. Here is another 10 seconds, but the velocity is 2 meters per second. 2 meters per second. Now, the particle then comes to rest for a period of 20 seconds. That means the displacement no change. Okay, here is 20 seconds. Before returning to its starting point when t equals to 60. Now, A. Find the velocity of the particle during the last 20 seconds of its motion. So that means here is 20. Now, we know that velocity is basically displacement over time. Okay, so now means that I need to find out what is the displacement, right, that has been traveled by the particle, right, for the first 40 seconds. So basically it's like this. Let's say here is t equals to 0. Okay, so first 10 seconds means that here t equals to 10. This is 50 meters. Alright, then when t equals to another 10 means that when t equals to 20, the v here, v is 2 meters per second. And then after that, when it reaches 20 seconds, right, then it will be rest for another 20 seconds here. So before it returns to the starting point, means that when it reaches 20 seconds, here when t equals to 40, right, then it will be going back. So here rest, this is rest. So then it's like this. Okay, so I will say then go back. Right? So when go back, so the t equals to 40. And then t equals to 60, it reaches the starting point. Okay, so from here, I need to find out what is the velocity. It means that I need to find out what is the displacement. So what is the displacement that the particle has traveled for the first 20 seconds? So first 10 seconds, it will be 50, right? So I will write here from 0 to 10 seconds, the s is 50. Now from 10 to 20 seconds, given the velocity is 2, so now my s equals to ut. Okay, so it's 2 times 10 seconds. That is 20 meters. So from here, I know that from 0 to 20 seconds, the total distance traveled it will be 50 plus 20. That is 70. Okay, 70 meters. Then it rests for 20 seconds. After that, he travels back. Means that here also 70 meters. Right, but then since we are counting velocity, that means now from 0 to 40, from 40 to 60 seconds. Okay, so the s, which is a displacement, will be negative 70 because it's in the opposite direction. So then the v, velocity, v equals to s over t. This is going to be negative 70 over 20. Then I get negative 7 over 2. That is negative 3.5 meter per second. Now the negative means that it is traveling back to the initial point. So now B, sketch a velocity time graph for the motion of the particle from t equals to 0 to t equals to 60. Alright, so now from 0 to 10, we know that the displacement is 50. So now the velocity, it will be s over t. That is 50 over 10. Then I will be getting 5 meter per second. Right, 5 meters per second. Then from 10 to 20, the v is given 2 meter per second. So from 20 to 40, okay, because it is at rest, therefore v equals to 0. Then from 40 to 60, then the v is negative 3.5. Okay, so now from based on these 4 values, I would say that we are able to sketch the v against t. Okay, let's say my highest v is 5. 1, 2, 3, 4, 5. Then now my lowest v is negative 3.5. Okay, so then the t is from 10 seconds, from 0 to 60 seconds. So now my graph, it will be 0 to 10, the v is 5. So 0 to 10, the v is 5. Then from 10 to 20, the v is 2. Okay, 20 to 40, it is 0. Then 40 to 60, the v is negative 3.5. So this is the velocity time graph. So I should label my velocity, the unit, as meter per second, and then the time is seconds. Alright, so done for the part B. Okay, now for question number 2, a particle is projected vertically upwards from the horizontal ground. The speed of the particle 2 seconds after it is projected is 5 meter per second, and it is traveling down. Okay, so A, find the speed of projection of the particle, which means this is the particle, okay, projected upwards. Then when it is t equals to 2, it is projected as, so means that the v is 5 meter per second and it is traveling downwards. Alright, so from here, this is the u. This is the speed of the projection. So now, since this is downwards, so I will consider moving down as positive. So v equals to u plus at. And now we need to find out what is the u. So now my v is 5 because it is traveling down. Then the u becomes minus u because it's in the opposite direction. Right? Then the a is going down. I mean, it is because now the motion is going down. So the a is positive 10. And then the t is 2. Then from here, I will get u, right? To get the u, just move the minus u to the other side, the 5 to right side. So from here, I will be getting u equals to 20 minus 5, that is 15 meter per second. Alright, so done for A. Now B, find the distance traveled by the particle between the 2 times at which its speed is 10 meter per second. So from here, I know that initially it was projected with 15 meter per second. When it comes to the highest point, it will stop a while. Okay, and when we know that when it is going up, right, projected upwards, the speed is decreasing. So it means that 2 times at which the speed is 10 meters per second means that like this. This is u equals to 15. Okay, going up. Then from here, I will say probably this is t equals to 10. I mean u equals to 10. Okay, this is u1. u1 equals to 10. This is u2 equals to 10. And then here will be 0. Alright. Now probably I write here v equals to 0. Then now you need to find out what is the distance, the s. So I need to find out what is the s here. And also, wait, I should draw like this. Okay, so I need to find out what is the s over here and then the s over here. Alright, so from here I can just use this motion when it is reaches the highest point and go down. Okay, so what is the distance? So then I will just write v squared equals to u squared plus 2as. I consider moving down from the highest point. So the v is 10, so 10 squared, u is 0 because we refer to the highest point, plus since this is going down, the a is 10 positive. Then find out the s. So I will get 100 equals to 20s, therefore my s is 5. So then the distance, it will be 5 plus 5, that is 10 meters. Okay, so done for this question. Now for question number 3, a crate of mass 600 kg is being pulled up a line of greater slope of a rough plane at a constant speed. Okay, constant speed means that the a equals to 0. Okay, the u or v equals to 2. Now, the plane is inclined at an angle of 30 degrees to the horizontal and the rope is parallel to the plane. The winch is working at a constant rate of 8 kilowatt. So this is the power. Right. So now, find the coefficient of friction between the crate and the plane. So I will draw the diagram. Okay. So let's say this is the plane inclined at 30 degrees. Okay. Now, this is the crate, 600 kilograms. So here I will label 600G, and then it is a rough plane. Rough plane. Okay, it is pulled up by the line, right? That means here, and the v is 2 meters per second. Then the a equals to 0 because of constant speed. Now, because of rough plane, that means it will have the frictional force. This is your Fr, frictional force. Then our R is always perpendicular to the plane. So that means here, I will label this is R. And the blue color is the mass. It's a weight. Okay, weight is mg. So now, I will say that the angle here is 30 degrees. This is 30 degrees. Okay, now from here, because you are given the power of 8 kilowatt, so I will say this is a driving force, right? So P equals to dV. The D is a driving force. So 8 kilowatt, it will be 8,000 watt. The driving force is unknown. The V is given 2 meter per second. So from here, my D is 4,000. Okay, so now to get the frictional force, to get the coefficient of friction, this is the mu. because your F equals to Fr equals to mu R. Then now, since this crest is moving up, that means I will use the Newton's second law. Okay, so whereby the A equals to 0 because of constant speed. So since this is going up, so going up is considered positive. So now I have to resolve all the forces. Now, of course, at first the D is moving up, alright, the D is pointing upwards, and then minus Fr because the Fr is in the opposite direction, and then at the same time I need to resolve this 600 G. So I'm using this angle. No, sorry. This supposedly I use this angle, but then this angle is unknown. I will be using 30 degrees. Okay, or you can say that the yellow angle is basically 60 degrees. So I'm using 30 degrees. So then it will be minus 600 G, because when you resolve, it will be in the same direction as Fr, the frictional force. Then now I'm using 30 degrees, therefore it is sine. If you are using the yellow angle, that is cos. Okay, then equals to MA. M is 600, the A is 0. Okay, now here your Fr is mu R. Mu is the coefficient of friction that we need to calculate. Then from here, I will say 4000, because the D already found, minus mu, my R, when you refer to the R is basically after you resolve the 600 G towards the to the angle of 30 degrees, the green color, then you'll be getting the R. So from here, I will be getting 600 G. Since I'm using the angle of 30 degrees, that is cos 30 degrees. And then minus 600 G sine 30 degrees. Right side will be 0. Okay, then from here, I will get 4000 minus, okay, now the question says you need to find out mu. That means this whole term I will move to the other side. Okay, so I will solve 6000. The G is 10. Sine 30 is half. Then equals to mu of 600. The G is 10. Cos 30 is square root 3 over 2. Okay, then from here, for the left hand side, this is basically 6000 times 5, right? Yes, 6000 times, no, 600, because it's 600 G, okay, mistake. 600 times 5, so that is 3000. So 4000 minus 3000 equals to, for the right hand side, you will be getting 3000 square root 3 mu. Okay, so now your mu is going to be 1000 on the right side, on the other side, over 3000 square root 3. Okay, so the thousands can be cancelled off. That means it's basically 1 over 3 root 3. But we seldom leave our square root 3 in the denominator. That means now you need to rationalize it. So you times square root 3 over square root 3. So the numerator is square root 3. Denominator is 3 square root 3 square root 3. That is 9. So this is your friction, coefficient of friction, which is a mu. Okay, question number 4. 4 coplanar forces at a point. The magnitudes of the forces are F newtons, 2F, 3F, and 30 newtons. The directions of the forces are as shown in the diagram. Now, given that the forces are in equilibrium means that they are not moving. Okay, the upwards and downwards force is equals to downward force, left force equals to right force. That is the meaning of equilibrium. Now find the value of F and the theta. Okay, so now here I need to resolve. Okay, I resolve horizontally first. So when I resolve horizontally, when you look at this arrow, means that the forces towards right side is positive. Okay, or I will say that I will equate them. So now what to do is these 2F newtons will be resolved to the right side. So it will be in the same direction as 3F. So it will be 3F plus 2F. Okay, here is 45. Obviously, this is also 45 because here is 90 degrees. Right? So one whole straight line is 180 degrees. So it means that I know that that is 45 degrees. Then you can just write cos 45 degrees. Otherwise, you can use the given 45. That is sine. But sine 45 is same as cos 45. And then at the same time, I resolve this 30 degrees towards the theta degrees. I resolve the 30 newtons towards the theta degrees. That is cos. So this is going to be 30 cos theta. Then from here, right, I will say 30 cos theta equals to 3F. Okay, I will take out the F at the back plus 2. The cos 45 is 1 over square root 2. So end up with 3 plus 2 over root 2F. That is my first equation. Okay, now I will resolve vertically, upwards. So when I resolve upwards, right, this 30 newtons will be resolved upwards by using the alternate angle. Therefore, it is 30 sine theta. So I will be getting 30 sine theta that equals to, now for the downwards forces, I have Fn, F newtons, and I have to resolve this to F. Then now I will resolve using this 45 degrees. That is 2F cos 45 degrees. So then I will be getting F plus 2F cos 45 degrees. Okay, so now 30 sine theta equals to, by factorizing the F, the first term left 1, and then the second term is basically 2 bracket 1 over square root 2. This is same as 1 plus 2 over root 2 F. Okay, now the question says you need to find F and theta. So now I will just divide, because I know that sine theta over cos theta is tangent theta. So I will use the second over the first equation. Therefore, 30 sine theta over 30 cos theta, that is tangent theta. Okay, for the right side, 1 plus 2 over root 2 F divided by 3 plus 2 over root 2 F. So the F will be cancelled off. Okay, then for the right hand side, when you simplify, that is 0.546918. So therefore, your theta is inverse tangent of this value. Okay, inverse tangent of 0.546918, that is 28.675 degrees. And now I will just write my theta is basically 28.7 degrees. Now, for the calculation of the F, okay, I will use the first equation. So from first equation, 30 cos theta, that equals to 3 plus 2 root 2, 3 plus 2 over square root 2 F. Okay, now for your information, the theta don't use the final answer because the calculation we use more decimal places, 28.675 degrees. Then you will get more accurate answers. So then from here, my F just move down this 3 plus 2 over root 2 to the other side. So it will be 30 cos 28.675 degrees over 3 plus 2 over root 2. Then this is going to be 5.9627, and at last, round up to 3 significant figures, then you will get 5.96. So that is the F. Okay, next question number 5. A particle moves in a straight line starting from a point O. The velocity v of the particle s after of the particle ts, t seconds, after leaving O is given by the expression. Okay, so now you may assume that the velocity of the particle is positive for t less than half, and is 0 when t equals to half, and is negative when t is greater than half. Find the distance traveled between t equals to 0 and t equals to half. Now, v equals to ds over dt. That means your s is integrate v dt. So now we need to do integration. So s equals to integrate from 0 to half. This expression, t cubed minus 9 over 2 t squared plus 1 with respect to time. So for your information, when you integrate x degree n dx, this is going to be x degree n plus 1 over n plus 1, then plus c. So now, provided the n is not minus 1, this is the integration formula. Now here, I will be getting t degree 4 over 4 minus 9 over 2 t cubed, t squared becomes t cubed over 3, then the plus 1 becomes plus t with limits 0 to half. Then now here, I will simplify. Now it will be t degree 4 over 4. Okay, the 9 over 3 can be simplified. This is 3. So it means that I will be getting minus 3 over 2 t cubed. Then plus t, limits from 0 to half. So here, replace the t by half first by factorizing the 1 over 4. Then I'll get 1 over 4 times half degree 4 minus 3 over 2 times half degree 3 plus half, then minus, when the t is replaced by 0, everything is 0. Then now you will be getting 1 over 64 minus 3 over 64 plus half. So at last, that is going to be 21 over 64. So that is the distance traveled. Okay, B. Find the positive value of t, only one t, at which the acceleration is 0. That is the first part. Hence, find the total distance traveled between t equals to 0 and this instant. So now, acceleration is dv over dt. So now the v is t cubed minus 9 over 2 t squared plus 1 when the t is from 0 to 4. So now I need to differentiate. So now my a, for your information, when you differentiate x degree n with respect to x, that is nx degree n minus 1. So which means here, the t cubed becomes 3t squared minus 9 over 2 t squared becomes 2t. The plus 1 becomes 0 because there's no t. So now here my a is basically 3t squared minus 9t, and acceleration is 0. So a equals to 0. That means now the common term is 3t. So you can factorize 3t. Then you will be getting t minus 3 equals to 0. Hence, either 3t equals to 0 or t minus 3 equals to 0. So now my t equals to 0 or my t equals to 3. Okay, so the positive t, therefore we have to choose t equals to 3. That is a positive t value. Now, hence find the total distance. Okay, I have to rewrite. See here. The v is positive. When you refer to the question here, the v is positive. Okay, assume the velocity is positive when t less than half. That means 0 to half, it is positive. Then when t exactly half, the v is 0. Okay, so v equals to 0 when t exactly half. But then we know that this is true for 0 to 4. That means when more than half, right, that means t more than half, it will be up to 4. then the V is negative, as given in the question here. Negative when t is greater than half. Okay, now what to do here is you need to calculate the distance, right? And now this V is the velocity. So that means now we know that S equals to integrate V dt. And according to the question, the total distance traveled between 0 seconds and this instance means t equals to 3. So when t equals to 3 means that you have to consider up to here, right? So now when that means when you look at these three values, right, that means when here t equals to 0 until half, right, the V is positive. That means going to the right side. After that, stop, rest, because V equals to 0 but exactly half. Then it goes back because V equals to 0. V less than 0. It turns back. Okay, so this is t equals to 4. So now V goes back. That means the displacement will be negative. But then now you are counting distance. And then we are given velocity expression. This is a velocity. So it means that even though we are doing integration, but we need to put a modulus because otherwise it will be a negative value. So it will be from 0 to half the V. Okay, V dt plus absolute value from the t from half to 3 V dt. Because that is, if you never put the modulus, that is the displacement, then you will get negative. But now we are counting distance. So from the first part, okay, from 0 to half, already counted as 21 over 64. So I will just copy the answer from the previous part and then recalculate the integration. So the integration, you just copy this result. Okay, copy these three terms and then change the limits. So it will be t degree 4 over 4, then minus 3 over 2, which is here, minus 3 over 2 t cubed and plus t. So minus 3 over 2 t cubed plus t, and then with limits half to 3. Okay, so now just need to do the calculation for the next part. So here is going to be, okay, replace the t by 3 first. So 1 over 4, 3 degree 4 minus 3 over 2 times 3 cubed plus 3 minus when the t is half. So 1 over 4 half degree 4 minus 3 over 2 half degree 3 plus half. Just replace accordingly. Then you will be getting 21 over 64 plus absolute value of 81 over 4 minus 81 over 2 plus 3 minus 21 over 64. Then here is going to be 21 over 64 plus absolute value of the total is negative 1125 over 64. Then now, after the modulus, after the absolute sign, it will be positive. Then you will be getting 573 over 32. And at last, this is going to be 17 and 29 over 32 meters. So that is the distance traveled by the particle. Okay, now for question number 6. A car of mass 1,800 kilogram is towing a trailer of mass 300 kilogram up. Okay, 300 kilograms up a straight route incline at an alpha, angle alpha to the horizontal, where sine alpha is 0.05. The car and trailer are connected by a tow bar, which is light and rigid and is parallel to the road. There is a resistance force of 800 newtons acting on the car and a resistance force of F newtons acting on the trailer. the driving force of the car's engine is 3000 newtons. Now A, given that F is 100. Okay, so this is 100. Now find the acceleration of the car and the tension. So here we have two parts, acceleration and tension in the tow bar. Okay, so this is the diagram. Here is alpha. So sine alpha is 0.05. And then this is the car. Okay, so this, and then here is the trailer, right? Okay, 1800 G as the weight, and then 300 kilograms. So this is 300 G. Now there's a driving force D. So resistance force 800 newtons on the car, X on the car. So this is 800. And then here you will have the tension. And the resistance force of 100 newtons on the trailer. So this is my 100 newtons. Okay, so now we need to find acceleration and the tension. So from here I can just consider the whole system. Okay, F equals to ma, the Newton's second law, and I'm considering the forces parallel to the plane. So F equals to ma. Now this is going up, so A is positive when it is moving up. Means that all forces pointing upwards will be considered positive. Firstly, okay, the driving force is 3000, so this is 3000. So now I will say 3000 minus the 1800. Okay, so here, look at here, this is alpha, here is alpha. Alright, this is 300 G. Now I will resolve this 1800 towards the, parallel to the plane. This 300 G will be resolved as well. So after you resolve, basically the rest of the forces will be in the opposite direction of the driving force. Okay, so it means that now I will have to minus 1800 G. So when I resolve horizontal to the parallel, resolve this 1800 parallel to the plane, okay, in this direction, I am using the angle alpha, alternate angle, therefore that is sine. So here I will write sine alpha. Okay, then I minus 800, there is a resistance force acts on the car, and minus the 300 G, you also resolve it towards the plane that is using alternate angle. Okay, because your angle here, this angle is not given. This angle is not given. So I'm using the alpha angle. Therefore, you will be getting sine alpha. Okay, and then now don't forget the minus 100 because there is a resistance force act on the trailer that equals to ma. The m is total because I'm considering system. So the total of trailers and the car will be 1800 plus 300. That is my total mass. And then the A, okay, the A just remains, right? Because you need to calculate what is the A and the T. T we find later, okay, the tension. So now here is to find the A first, the acceleration. So that means now I will be getting, okay, this is 3000, the D. So I will get 1800 plus 300 is 2100. So I will rewrite 2100A equals to 3000 minus 1800. The G is replaced by 10. Sine alpha is given in the question, which is 0.05. So these two values will be replaced by 0.05. Then minus 800 minus 300 times 10. The G is 10. Sine alpha is 0.05. Then minus another 100. Then from here, okay, you will be getting right side as 1050. Left hand side remains as 2100A. Therefore, my A is 1050 over 2100. That is 0.5. So I found the acceleration. Now for the tension, I will refer to the car. You can refer to car or you can refer to the trailer. So for the car, alright, so I will just consider these parts now. That means the forces involved will be D, 1800, G, 800, and also the T. Just refer to the car. So which means now I will be getting, again use F equals to MA, going up as positive. So I will get my F is 3000, which is a driving force, minus the rest of the forces. Now it will be these two. Okay, it will be these two together with the T. Alright, so here I will write minus T minus 800 minus 1800 G sine alpha. Then my M now is just for the car. So car is 1800 kilograms. And then the A we have found 0.5. Then from here, to find the T, this T, because it's negative, so I will move this T minus T to the right side. And the 1800 times 0.5 will be moved to the other side. So then from here, I will get 3000 minus 800 minus 1800, 10, sine alpha is 0.05, then minus 1800 times 0.5. So when you calculate all the values on the right side, that is going to be 400. So that is the tension. Okay, now next part, B. It is given instead that the total work done against F in moving a distance of 50 meters up the route is 6000 joule. The speed at the car at the start of the 50 meters is 20 meter per second. Now use an energy method to find the speed of the car at the end of 50 meters. Okay, so now here, this is alpha. At first, you are here now. This is a car, okay, together with a trailer. So it's mentioned that moving up 50 meters. So it becomes here now, 50 meters. That means here is 50 meters. Alright. So then the question says the speed of the car at the start of 50 meters. So here the V equals to 20. Alright. So using energy method. So now work energy principle, refer to this principle. The total work done, probably you can just write net work done. Right, net work done or total work done, up to you. It will be the increase in mechanical energy. Okay, so now net work done is basically work done by the car engine. You minus work done against the resistance force. Then increase in mechanical energy. This is basically increase in kinetic energy plus increase in potential gravitational potential energy. Okay, so now work done by a car engine. Work done by a car engine just now. We know that work done is F times D. So the driving force is 3000. Okay, 3000. And then the D is basically the distance traveled, which is 50 now. Then you minus work done against the resistance force. Okay, so this is going to be 6000 joule. And don't forget, now from the previous part, we know that there will be a resistance force of 800 acting on the car. Okay, so that means now here I have to minus 800 times 50. This is a resistance force acting on the car. That equals to, now increase in the kinetic energy is basically the final KE. The final KE, the KE is half mv squared, right? You minus the u squared. Final KE minus the initial KE. The GPE is mgh. Then minus the original h, right? So minus the initial GPE. So then from here, I will say half. So increase in KE. So the total mass is 1800 plus 300. Okay. So now you multiply with V squared because that is the V that you need to count. V speed of the car at the end of 50 meters minus the initial speed is 20. So you minus 20 squared. Okay, then you plus with mgh. So m is 1800 plus 300. The g is 10. Now what is the h? So the h is basically here. Okay, you need to find out what is the h here. So we know that here is alpha, right? And this is 50. So refer to the Pythagoras theorem, not Pythagoras theorem, the what is that called? This is the opposite side, and here is the hypotenuse. So opposite and hypotenuse, that is sine. Okay, so which means I will say that my h, you can say right here, sine alpha is h over 50. So the h is 50 sine alpha, right? So here the h is 50 sine alpha. Initial h will be 0. Then from here, right, to find the v, so for the left hand side, I will be getting 104,000. That is the total of the left hand side. Then my right hand side is half. 1800 plus 300 is basically 2100. Then v squared, right? So here you can just write v squared. Then now here you can just do expansion. So it will be minus 420,000. Then plus, okay, so this is going to be 2100 times 10 times 50. Sine alpha is 0.05. Then to get the v, right, so I will keep this on one side and the rest of the terms will be moved to the other side. So then from here you will be getting 2100 over 2. That is 1050 v squared equals to 104,000. The minus 420,000, it will be plus 420,000. Then minus the total of these values, it will be 5 to 500. So I will just calculate, right? Then the right hand side will be giving you the value of 471500. So then V squared is basically 471500 over 1050, and then this is going to be 9430 over 21. And now we need to find the V. So the V will be square root of this value because that is speed. So it will be positive value. And you will be getting 21.1907. Now round up to 3 significant figures. So the V is 21.2. Okay, so that is how we solve the speed at the end of the 50 meters. Now for question number 7, okay, given this diagram, now the diagram shows two particles P and Q which lie on the line of greatest slope of the plane ABC. Now particles P and Q are each of mass m kilogram. So that means here is mg. This is mg. Right. Now the plane is inclined as an angle of theta to the horizontal where sine theta is 0.6. The length of AB is 0.75, which is given here, and the length of BC is 3.25. The section AB of the plane is smooth, and the section BC is rough. Okay, BC is rough. This is rough plane. The coefficient of friction between each particle and the section BC is 0.25. This is the mu. Particle P is released from rest at A. So when release means the U equals to 0. At the same instance, the particle Q is released from rest from B. So the UQ is 0, the UP is 0. Now A, verify that the particle P reaches B 0.5 seconds after it is released with speed 3 meters per second. So now we need to show the V is 3 and the T is 0.5 when it reaches B. That means it has traveled for 0.75 meters. So now since this is in the inclined plane, we need to find out what is the A first, the acceleration. So now I will just write F equals to MA. Consider the points P. Okay, consider the points P. Going down. So F equals to MA. That means the A will be positive and all the forces in this direction will be positive. So now I will have to resolve because this is theta. That means my theta, it will be over here. Okay. So when I resolve the mg, where I'm using the alternate angle, okay, I resolve so that it is in this direction. So it will be mg sine theta. So here I will write mg sine theta equals to ma. So then the A is basically g sine theta. So g sine theta, the g is 10 and sine theta is given 0.6. Therefore, it is 6. So now, after that, I need to show the V and T. And I have S equals to 0.75. Okay, A equals to 6. Then now I can just write my V square equals to U equals to 0 because it's released. So V square equals to U square plus 2AS. Now, since the particle is moving down in this direction, which is parallel to the plane going down, and I have assumed going down as positive, so now the V squared, the U is 0, the A is positive 6, and the S is 0.75. Then from here, the right side will be 9. Therefore, your V is 3. Okay, and now we need to show T equals to 0.5. So then I can just write V equals to U plus AT. So when it reaches B, the V is 3, the U is 0, A is 6, and then t remains. So 6t equals to 3. Therefore, t equals to 3 over 6, which is 0.5. So here we have shown. Right? Done for this question. Now B, find the time that it takes from instance that two particles release until they collide. Okay, so now from here, because this P moving up down, this Q also moving down, probably they collide here. Alright, so this is P and this is Q. So I will say that for the particle P, I will just refer to particle P. Right, so for probably I just write P. Okay, I need to find out what is my I use back F equals to MA. Then from here I need to find out what is the A when it, because we have found the A over here. Right, so from P to Q, I mean from A to B, I found that the A is basically 6 meter per second squared. But then what happens when it is traveling from B towards C? Okay, so here because of the rough plane, right? Rough plane, you will have to consider the frictional force. Okay, so that means now when I refer to the points P, let's say I draw this diagram. This is my B. Okay, then here, this is my P. It moves down. So then the frictional force will be going up. This is Fr. Here, the angle is given theta, 0.6 sine theta. So sine theta is 0.6, right? That means this one is going down. I should use different color. The B is mg. And then my angle is over here. This is my theta. Okay, and at the same time, my R. Here is my R. Wait, my R should be going up, not going down, because it's on the plane. This is my R. Okay, so now I know that sine theta equals to 0.6, right? So from here, I will say when I consider the Newton's second law, again going down in this direction, my F equals to MA. I need to find out what is my A first, because now it is traveled on the rough plane, no longer 6. So when I resolve, I got to resolve this mg right towards the plane. Therefore, I'm using this theta value. That is the alternate angle. Okay, or I'm using this theta. Therefore, I will be writing mg sine theta going down. And then I have Fr here. So minus Fr. Fr is my mu r. Okay, so now given that the mu is 0.25, so I will write minus 0.25. This is 0.25 r. So then this is going to be, my r is basically, you resolve this mg vertically. I would say perpendicularly to the plane. That is mg cos theta. That equals to ma. Now from here, all my m will be cancelled off. Okay, then I will be getting my a as g sine theta. G is 10. Sine theta is 0.6 minus 0.25. G is 10. Cos theta. Okay, now look at here. Sine theta is 0.6. Okay, so sine theta is 0.6. That means theta is inverse sine 0.6. That is going to be 36.8699 degrees. Then I will just say this is 36.87 degrees. Because I need that value for the calculation, that's why I give two decimal places. And then when you calculate this, that is going to be 4. So it means that from B to C, okay, the A reduced to 4 meter per second. So now I need to find out when it enters, it passes through points B, so it will collide with the Q, okay, in between B and C, or yeah, in between B and C, because B moving down with the frictional force. So now I will just write S equals to UT plus half AT squared. So when they collide, means that there will be the particle P and Q will be having the will be traveled with the same distance, okay, from B onwards. So I will calculate from B onwards. So now my particle P, when it reaches B, the speed is 3, okay. So that means the U here is basically 3. Then T is unknown because you need to find what is the time. What is the time over here? That means now here plus half the A becomes 4. Then T squared. So this is going to be 3T plus 2T squared for the SP when this is from B onwards. Okay, this is your SP, first equation. Now for the SQ, the distance traveled by the particle Q. So now we consider when starting from B. So when starting from B, the initial speed is 0 for the Q. Therefore, UT plus half AT will be 0 times T plus half. Okay, the A still 4 because it is the same plane, rough plane, which is 4. And then now the T, remember, you see, the T here means the T counted when the P reaches B. So here is the T. Okay, and then now don't forget, the before the P reaches B, it has traveled for 0.5 seconds because the P starting from the A. So means that for the Q, the distance will be, the Q has been traveled for T plus 0.5 seconds. Okay, because when P reaches B, it has been 0.5 seconds, right? So means that now here it will be T plus 0.5. Okay, then T squared. So from here I simplify half times 4, that is 2. So 2 times T plus 0.5 squared, that is my SQ, second equation. So when they collide means that SP equals to SQ. So then just need to solve these two simultaneous equations. Okay, so just do expansion. For the right side, that is T squared plus half T, 0.5 T times 2, that is T. Then plus square of 0.5, that is 0.25. And do the calculation for right side, 2T squared plus 2T plus 0.5. Right side is 3T plus 2T squared. So obviously the 2T squared will be cancelled off. Okay, then this 2T move to left side becomes 1T. So I get T equals to 0.5. Now, this T equals to 0.5, that is from B to C, okay, from B to C. But then the question says, what is the time it takes from instance the two particles are released? Release means from the beginning. Okay, so now I will say time taken, it will be 0.5. This is probably I will write here. Okay, time taken, it will be the time from A to B plus the time from B along B to C. Okay, this is B to C. So that means this is going to be 0.5 plus 0.5. That is 1 second. Okay, it is not really reaches C when they collide, but it is just from B onwards. Okay, from B onwards. So that's why BC here lah. Okay, then now the two particles collides when they collide. The coefficient of friction between the combined particle and the plane is still 0.25. C. Find the time it takes from instance the particles collide until the combined particle reaches C. Okay, so that means now, right, this is your diagram. This is a B. Okay, here is P. The U here is 3 meter per second. So I let it be U. Now, it will travel for t equals to 0.5. Then it will collide with the Q. Okay, this is Q. This is P. Then now, probably I have to redraw, enlarge the diagram. Okay, P and Q. And now it is C. So reaches C. Let's say this is a C. So here, P and Q. Now we know that BC is with distance of 3.25 meters. So now here, 3.25. Okay, this is a C. Now, I need to find out what is the time taken when from collide. So it means that I need to find out what is this time from the instance that collide until that reaches C. Okay, so now first of all I need to find out what is the velocity or what is the speed of the P before the collision. So now V equals to U plus AT. Okay, before collision of P with Q. Okay, because I know that here is U equals to 3 meter per second when it reaches B. But before it reaches, before the P collide with the Q, what is the V there? So VP equals to UP plus AT. So the UP now it becomes 3, the A is 4, and when they collide, that is 0.5 seconds. We have found it in previous parts, that is 5. Means that before it collides, the VP is 5. And then at the same time, the VQ, okay, U plus AT, the T is T plus 0.5. Then the U is 0 because we are counting from the B. So the particle Q is released from the B. So then the A is still 4, the T is 0.5, then plus another 0.5. Obviously, it is 4 meter per second. Now, here, I need to find when they combine together, what is their V? Okay, so linear momentum. We are referring to the linear momentum now. Linear momentum before the collision. Because to find the T, I need to know what is the V here. Okay, or what is the U there, right? So before collision equals to after collision. So before collision is MP VP plus MQ VQ. Then after collision, both combine together. MP plus MQ traveled with V. So now the VP is 5, the MP is M, okay, VQ is 4, MQ is M as well. So the MP plus MQ is basically M plus M times V. So 9M is 2MV. So then the M will be cancelled off from both sides. So your V is 9 over 2. That is 4.5 meter per second. Means that once they combine together, they are traveling at 4.5 meters per second. Now, I need to find the time from collide, starting when they combine together until reaches C. So it means that I need to find out actually before they combine, right? What is the distance that P has traveled from the B? So what is the S over here? What is the S? Okay, because I know that this is 3.25. So once I found the S from P when until they collide together, then I can know what is the S for the remaining distance. So now I need to write down, I need to calculate distance from B when particles combine. So I refer to particle P. So S equals to UT plus half AT squared. So then from here, I know that my U is 3 because when the P reaches B, the U equals to P, the speed is P, the T is 0.5, plus half, the A is 4, the T is 0.5. But if you consider the point Q, the particle Q, the T, it will be 1. Okay, so then this is going to be 2. So okay, when you refer to Q, S equals to UT plus half AT squared, that will be 0 times 1. I will just write 0. Okay, 0, because initially was 0. Half 4 times 1 squared. That will be 2 as well. So then means that it has traveled for 2 meters. The S is 2. So if the S is 2, I know the remaining distance. It will be 1.25 then. Okay, so then now from here, I will just write the remaining distance from collision to C, that is 3.25 minus 2, that is 1.25 meters. So with this S, I can find the time, okay, because we have found the V here, V. So now S equals to VT plus half AT squared. So the S is 1.25, the V is 4.5, okay, which is here. This is the V, 4.5, and then the T is unknown, plus half. Since the B and C is rough plane, the A will be 4, then remains T squared. So then I will get 1.25 equals to 4.5T plus 2T squared. So rearrange this to get a quadratic equation. So probably I'll solve it here. Then here it will be getting 2T squared plus 9 over 2T minus 5 over 4 equals to 0, because I moved the 1.25 to the right side and I write all the decimal in fraction. So then from here get times 2 for the whole equation, or times 4 to the whole equation. You will get 8T squared plus 18T minus 5 equals to 0. And this quadratic can be factorized into 4T minus 1 times 2T plus 5 equals to 0. So now either 4T minus 1 equals to 0, that means your T is 1 over 4, or 2T plus 5 equals to 0, then your T is negative 5 over 2. That is negative 2.5. So the T cannot be negative. That means from here, your final answer T is 1 over 4, which is 0.25. That means it takes 0.25 seconds to reach C after they collide. Okay. So this is the solution of whole question. Okay, now we have come to the end of the video. Thanks for watching. If you enjoy watching my video, again, please like and subscribe to the channel, and also share this channel with your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.